Dear students, in this video we will study organic chemistry of Igcse level. So let's start with the basics of organic chemistry. We'll start with the basics. What exactly are organic compounds and how do we draw them using different types of formulas? Then, we'll learn the secret language chemists use to name these millions of molecules. And finally, we'll discover the simple general formulas that help us predict what a compound is made of, just by looking at its name. Organic chemistry is the study of how carbon forms the foundation of all life. It's the branch of science that explores the structure, properties, and reactions of organic compounds. These organic compounds are defined by one key element: they all contain carbon. Now, let's look at the most basic building blocks of organic compounds, hydrocarbons. As their name suggests, these are molecules made of nothing but hydrogen and carbon atoms. They form the basic skeletons of countless more complex molecules. Ever seen a chemical name like ethanol and wondered, what does that molecule actually look like? In organic chemistry, we use different types of formulas to answer that exact question. Molecular formulae. The molecular formula is the actual number of atoms of each element in a compound. Displayed formulae. The displayed formula shows the spatial arrangement of all the atoms and bonds in a molecule. Structural formulae. In structural formulae, enough information is shown to make the structure clear, but most of the actual covalent bonds are omitted. Molecular formula of ethane is C2H6 and it tells you that ethane contains exactly 2 carbon atoms and 6 hydrogen atoms. Structural formula shows the arrangement of atoms in a compound, but it doesn't show all the bonds. It tells us that there are 2 methyl groups, CH3, bonded together with a single bond. Displayed formula is the most detailed representation. It shows the spatial arrangement of all the atoms and every single covalent bond in the molecule. It tells us that each carbon atom is bonded to 3 hydrogen atoms and 1 other carbon atom, and that all the bonds are single covalent bonds. Next we need to talk about. Because millions of organic compounds exist, they're named using a systematic method. All organic compounds are named using a system based on the structure of the molecule. Now let's discuss about families of organic compounds. Can be described by looking at end of name. If it is end at -ane, so compound is alkane. If it is end -phene at -ene, so compound is alkene. If OL, so it is an alcohol. If OIC acid, so it is an acid. Let's describe homologous series. There are some key characteristics of homologous series. All members of a homologous series share the same functional group. The compounds in a homologous series can be represented by a single, common general formula. Each member differs from the next by 1 CH2 unit. As the number of carbon atoms increases down the series, the physical properties of the compounds, such as boiling point, melting point, and density, change in a regular, predictable manner. Because they have the same functional group, all members of a homologous series undergo the same types of chemical reactions. Now let's discuss the general formulas for alkanes, alkenes, and alcohols and carboxylic acid. Alkanes are saturated hydrocarbons containing only single carbon-carbon bonds. Their general formula is CnH2n plus 2. Alkenes are unsaturated hydrocarbons that contain at least one carbon-carbon double bond. Their general formula is CnH2n. Alcohols are organic compounds characterized by a hydroxyl functional group, O, attached to an alkyl group. Their general formula is CnH2n plus 1O or R-O. Carboxylic acids are organic compounds that contain a carboxyl functional group, -COOH, CnH2n plus 1Cu. Thanks for watching. If you enjoyed this video, please like and subscribe so you don't